Greetings. I'm honored to have a full room, and I'm honored to talk today. But this is a talk from 3 people, not just myself. This talk has been growing, both on content and on the analytics behind it, from both Tom in our UK office, Jerome, myself, with help of other engineers. And what I'm going to do is I'm going to go through a route leak. Not the first, won't be the last, we all know that. But I'm going to go through this and sort of show you some of the sort of inside knowledge, and also point you, quite frankly, before you sort of want to flip through the slides on the NANOG website, there's a fairly in-depth pair of blogs which cover what I'm going to talk and go down into the absolute bit by bit, route by route, nitty-gritty. So in 30 minutes, I'm going to give you a bit of internet history. I've got gray hair, I'm allowed to do that. I'm going to talk about some leak history, and there won't be anything surprising there, that seems to happen. Then I'm going to talk to you about what happened June last year. I'm going to talk to you about the subject of route optimizers. And for part of the room, I'm going to talk about route optimizers. And I've got some graphs. So let's go back to not the beginning of the beginning of the beginning, but let's sort of go to what was becoming sort of the modern age of the ARPANET. And you've got these wonderful set of diagrams, all of which are archived out there. This is one I particularly like, because I'm an old PDP-11 guy, and there's a few PDP-11s, there's some 10s on this diagram. There's some great history on this diagram. But this isn't the internet that we run today. And the overriding part about the historical information that I'm going to share is that security wasn't part of the plan. Even if you go down to that transition of NCP to TCP and you start looking at the spec inside the protocol, which we still run today, RFC 791 is as valid today as the day it was written or published in the early 80s. Section 3.1 has security options and lots of bits, and I'm sure some people have actually read this, because in fact your include directory on any Linux box or BSD box or equivalent has got a whole bunch of include files with this defined in it. And yet basically no code ever uses it. Definitely no applications. In 1989, we start seeing the birth of the World Wide Web. Remember, that is not the internet. The internet is the internet and the web is the web. These are 2 different things. However, in that, the phrase that information exchange is still more important than security. Sorry, this is secrecy on this one. Sorry, rewind. Actually, let me just take a break. Just want to talk to the operators of the audio-visual for a second. The 30-minute timer that I have has not started. That will inject more of me talking to the people in the room. And in the interests of everybody here, it has now started. Thank you. If I may go back to my subject matter. So secrecy is a different metric than security, but it continues. In BGP3, security issues are not discussed in this memo. There seems to be a pattern, and that pattern, unfortunately, is the basis of a lot of what we do today when we talk about route security. So let's look at a diagram in whichever way you want to do it, but this diagram simply says that we used to have a connection that needed a name, and it needed to be converted via DNS to an IP, and that IP ran through a routing table with an ASN, and we ended up connecting. If we look these days, we have names and DNSSEC. We have CAs for that TLS style connection. We have RIRs and we have RPKI for ASNs and IPs. We are in a different world. We deal with encryption as the norm for our everyday use of the internet. And yet this talk is going to talk, obviously, about the lack of that at the routing level. But enough about history, but I'm going to show up a few old articles just to give you sort of one other aspect. This is what the press, this is what the rest of the world will publish in the case of a hiccup on the internet. And this is a couple of different events that occurred. And these articles get written on a regular basis. They just happen. Okay, so let's focus on what we know, BGP, and let's talk about what happens in that space. This is the sordid history of famous route leaks. I reckon a fairly good percentage of you know some of these, but I'm going to recap it anyway. In 1977, AS7007 did a phenomenally impressive job of completely deaggregating the internet and generated an enormous amount of routes. And it was not a happy day for those people that were on the internet running a BGP router on that day. 2008, we have the famous YouTube hiccup with Pakistan Telecom. We have other events that go on and on and on till we get to 2018 and then 2019, the one that I'm going to drill down on. And you sort of think, okay, it's only a few events, but the reality is that there's a lot more than this, and there are other talks later on in the day which will really drill down on some of the smaller events that have occurred. Because only a week ago, this occurred. A route leak from a random ASN of a set of IP addresses that are random until you notice what the pattern is here. And you realize this isn't just a typo. This is somebody's test lab or something that is leaking out and going to various parts of the global internet. This quad numbers this isn't just somebody typoing. And yet this goes, as I said, and has quite an effect. It's not that safe to run a quad number. Cloudflare has actually talked about the routing pluses and the routing minuses of announcing 1.1.1.1. It shows up in enormous numbers of test labs and other places by mistake. It shows up in hotels on Wi-Fi controllers, but it shows up on the global internet every now and again. Okay, so let's go down to the meat of the talk, and let's, after that nice background, talk about what happened. First of all, remember, the press is quite good at writing about this stuff. The press got out pretty damn quickly in talking about the fact that there was a route issue, and it affected us, it affected Cloudflare, and it affected us with a rather big hiccup. It affected lots of other people as well. We just so happened to be sort of the more visible network that was affected. And while press isn't good, it's important to understand that what we do as a network, as a set of networking engineers, as a set of networking operators, is now highly visible to the rest of the world. Somebody asked me earlier, you know, when did I first come to a NANOG meeting? And it was in the 90s, mid-90s. And there's not a hope in hell of a press person ever walking into a NANOG meeting or even knowing what routing tables were about. We have changed rather dramatically. So this route leak lasted about an hour and a bit. It started, it affected traffic. This is a graph from Sodexis. Sodexis is a company that measures content delivery network performance. And absolutely, as this route leak occurred, the performance of Cloudflare deteriorated. And it had a known start, and it absolutely had a known end. And when this happened, we get as many alerts as you'd expect us to get. And we had to deal with this, and we had to deal with it fairly quickly. It affected our traffic. This is an internal graph. I know there's no y-axis, but it started going down. It continued, and when it ended, it came back up again. We were down for that period of time. So how did we get it solved? And the answer is, and I can go on and on and on about this without any words on this slide, but you know the answer. We made phone calls, plural. And I have to tell you the story because it's sort of important. We very quickly realized that there was a route leak, and a very specific AS number was the cause, the source of those route leaks. And we picked up the phone and we talked to that AS number. We actually found the WHOIS information, returned a valid piece of information, and we picked up the phone. It was early working hours of the morning for them, East Coast. And they simply say, nope, not us. Thank you very much. Click. Now, the thing about routing tables, there's twofold. One is they're beautifully archived. Hats off and thank you to the people at Oregon, at Ripestat, CADA, other places that save routing tables ad infinitum. Secondly, when you look at a BGP route in a routing table and it has an AS number in it, it's pretty accurate. You know what's going on. You know the path. You know the players. Needless to say, we had to pick the phone back up again, and it took about, well, just shy of an hour to convince them that they really were the issue. By the way, this network was quite a sort of long way away and not very important. We didn't quite know what was going on still at this point in time. But this mechanism was our only mechanism to use at that point in time. Not perfectly formatted, but there is in fact actually, there's an RFC on what a route leak actually is. And so it isn't like we are talking about something that is to various players at this point in the mid outage time frame, that it isn't that we don't know what the language is. It's actually quite well understood. Here's an example of what that route table actually looked like to show you why we had sort of somewhat definitive information. We could see the particular AS number that shouldn't be in the route. We can see the path. This is what BGP is great at, that once you have enough of a view, you can actually see all of the different information. You can see the players involved. So we knew exactly who to pick up the phone and talk to. But there was a problem. And this becomes sort of the introduction to the second part of what I'm going to talk about in a few slides. This is not a route that we announce. We were seeing, if I go back to the previous slide, we were seeing a /21 that was being leaked. And yet, we only announce a /20. And the /20, in fact, actually is not only in the IRR, but is also RPKI signed with a max length of /20. Quick aside, and a very, very quick RPKI tutorial. You create a rower, and a rower has an IP address and an AS number. It has a net mask, we're familiar with that, but it also can have a max length. And the max length in this case equals the max length, the mask of the route. And therefore, that route can only exist as a /20 on the routing tables and nothing else. IRR says the same thing, except that it doesn't imply a max length. And this is nicely signed cryptographically. This is all good. But we were seeing as 21. But what was more interesting was where we were seeing it from. And so this is the RipeStat BGPlay tool. It can generate a very nice picture. In this case, we've augmented it with a set of names, and you'll see it play out where this route at the end here, where it says not Cloudflare, although it is our AS number on this specific play of this route, so equally on both sides, it is in fact actually not us. We don't connect through these other ASs in this particular way. So already at this point in time, we are starting to, to realize something else is going on. Why is this particular network here, which is named on the slide? It's very hard, by the way, to give one of these talks without naming names. Because, like I said, in the BGP world, everything is quite well documented. So, I told you we wrote 2 blogs about this. The first blog we wrote within a few hours after we fixed it, simply said what we really saw happening. And both of the URLs are here. Go grab them, read through them. It's the type of, I'm biased because I work for Cloudflare and I write blogs like this, but it is very much the mechanism of announcing what we are doing or what happened in a very flat, simple, factual way. And obviously fairly quickly. That does help. So the first one is simply, it went down, we think we know why. The second one actually contains a whole bunch of scripts, all of which were on GitHub. But the scripts were able to let anybody run the same analysis of this route leak. The data is out there. In this case, these scripts use the RipeStat capability, use their API, generate the correct API call, grab the JSON data, process it, do a whole set of whois's if you need to, and then find out what happens. And in the blog, it will give you the times down to, down to a second or whatever of when routes showed up and when they didn't. But it was very clear to us at this point in time, first of all, that the route that we saw was not the one we were announcing, and also the path was clearly coming from many other places. In the blog, I think we list all the different ASs that were affected during the same time. As I said, we seem to be the biggest one. All right, so I'm going to make an aside, because if I don't give a talk with the word IPv6 in it, I know some people will complain bitterly. But at this point in time, for this sort of hour and a bit, we had certain parts of the internet unable to access us via v4. So we had a whole set of websites that may be impacted during that time, depending upon where you are on the internet. But let's look at this v6 stat. This graph is the percentage of v6 activity coming in during that point in time. It went up. And it went up because, that happy eyeballs code that has sort of sat around and finally been implemented over the last sort of 5, 6, 7 years, 5 years? It has in fact actually saved the day for a large number of v6 enabled users. They failed to connect on v4, but because Happy Eyeballs is doing a v6 connection as well as v4 in parallel, They got to connect to us and get content via V6 for that period of time. Now, sadly, the graph goes down after this is fixed, meaning that there is an awful lot of bias towards V4 out there versus V6. And for those people that know me, I am not happy with the bias towards V4 versus V6. But anyway, interesting graph. At least it's another way of looking at what happened during that time. I'm going to talk about something else very quickly. There are, quite frankly, much better talks about peer lock out there. But very quickly, this was in the AS path that was in the particular leaked time. And during that leaked path, there are two ASs in this path that are clearly, or should clearly, not exist. A tier 1 network is, by its very definition, a network that does not need to use another network to get to the whole rest of the internet. And those tier 1 networks interconnect in a full mesh such that you never need to see two of their ASs separated in any way. They can be next to each other, but they can't be separated. There is no logical position for 174 next to 701 to also have a 3356 in there. These are the ASs of various tier 1s, level 3, now CenturyLink, Verizon, and Cogent at the beginning of this path. This is the link to the NANOG talk that Job Snyder gave, much better about peer lock. But here's a very simple diagram of what was going on. If we believe, without getting into an argument, that these are the various tier 1s that exist today, they all interconnect in a full mesh. Therefore, a route coming from a customer into one of those networks would only traverse this area of the internet once and then wander off to some other customer environment. It should never wander around and then come back into any of these ASs. And peer lock is the ability for a set of ASs to say, I will only listen to you through a direct connection, and I promise I will never see that route through anywhere else. And peer lock would have saved the day for this. Because as much as it isn't good to see this route leak, it really should never have traversed this area. Except it didn't. Because as good as peer lock is for tier 1s, et cetera, read Job Snyder's slides, the route never touched the particular AS which is in that BGP path in the first place. It was created by a route optimizer. So now, changing the subject slightly, route optimizers are about improving the internet for whichever customer plugs one in. It seems, and we seem to have the proof on this day, that it doesn't optimize it for the rest of us. A route optimizer injects routes in order to steer traffic within somebody's network by generating additional routes, by generating next hops, by generating AS paths that don't exist. And more importantly, and in this case explicitly, by generating more specific routes that will steer the traffic appropriately. A more specific route is got a higher priority. It will be used over a non-specific route. And in this case, these additional routes will be injected and cause traffic to move inside a specific network. Well, this is the same diagram. It doesn't have the same animation on it, but simply put, simply put, although RAS is there, as it was in the previous diagram, the route that I showed you with all that movement is in fact not our route. It is generated by a route optimizer, and it is out in the loose. It is out in the rest of the world. And the route optimizer has not kept the route within inside its particular customer network. Again, it's hard not to name names, but the route optimizer in question has a blog about whether it generates fake routes, and it has a tweet about whether it generates fake routes and whether the filter is there. And the reality is, do route optimizers cause fake routes? Yes. Do they have a book that sort of says that the routes won't leak? Actually, that's not true, because what they need to do is to make sure that routes don't leak by using standard methodologies. The no export option within BGP is as old as the hills. It isn't a newfangled community, it's a very old-fangled community. And it is specifically built for the likes of this. So if we look at what actually happened, you realize that we can go right back into the beginnings of the documentation, and you realize that this is sort of set up to fail if the route gets leaked. Now, they responded with that language. And part of this response is correct. So I want to make sure that I explain at this point in the story what is going on. Routes have been created by a route optimizer. Routes have exited the particular network that the route optimizer is on. Yeah, that's not good. But that particular other network doesn't own the routes anyway. So in theory, its upstream, its transit, would be filtering the routes, and therefore that would be the end of the story. And neither myself nor any of you, except for somebody maybe on that network in Pennsylvania, would actually see it. But unfortunately, and if you listened, by the way, to the keynote yesterday from Google, it was a brilliant story of, well, here was a bug, and here was another bug, and unfortunately everything happened at the same time, and something bad happened. And this is exactly the same thing. Somewhere in the world, filtering was missing at that point in time. And at that point in time, an optimizer leaked a bunch of routes. At that point in time. And at that point in time, all hell breaks loose. If either event had happened by itself, I wouldn't be here talking about it. But they all happened at the same time. So the incident can argue about this, and I can argue about this, and we'll never come to an agreement, but the reality is that obviously something bad happened. All right, so I mentioned RPKI. I will finish up by saying, look, RPKI. It isn't the be-all and end-all to solve the problem that we had on this particular day. It should be. It nearly could be. It would be nice to say that some networks, and I have that, like AT&T, KPN, Telia, a few others that are dropping RPKI invalids, would actually be immune to this type of event, because the route was invalid right from the start. It would be good to say that, but at the moment, we're not quite at 100%. We don't have every tier 1 running RPKI. But peer lock does seem to exist in a much greater sense within those players, and that is a good thing. I'm going to show you one other graph. And in this particular case, this graph contains, I keep hitting the wrong button. This graph contains CCOM in Africa. And CCOM runs RPKI. And in the RPKI world, they should be good. They should never touch this route. But it's very clear from this diagram that the route is propagating through their network. And here's the reason why. Mark Tinker from the network wrote on one of the IXs in South Africa onto the mailing list and basically said, because we don't use the ARIN TAL, because they don't use the RPKI data from ARIN, they in fact actually don't filter for ROAs in this particular area. That is a subject of a whole separate talk, and somebody should give it. No, I'm not going to talk about that slide. I'm going to talk about this one, though, very quickly, and then I'm going to be quiet. This is what happened to a particular network, an eyeball network, that didn't do filtering, and sure enough, that should not happen. Bits disappeared for a period of time. Here is a network that does do RPKI filtering and does peer-lock filtering, and nothing happened to them. So the good news is we sort of at least had a couple of eyeball networks to look at to see the difference here. Don't need to do that. That's simply rah-rah RPKI. And my summary is that I'm sure I'm going to get a bunch of questions. I thank you for listening. As I said, there are blogs which contain all the in-depth information on this. And I have gone over my time by 1 minute and 20 seconds, as expected. Name and affiliation.
Hi, Martin. Jared from Akamai Technologies. Yeah, so I mean, we also saw impact from this. I think as many people did, there were about 70,000 prefixes impacted as part of this. It was pretty broad ranging. I'm curious if you've had any better luck than I have since I had done some original research in a lightning talk in 2007 about how people should deploy simple techniques like AS path filtering when they're not able to do stuff. Some of that's come up with peer-lock, but I'm curious if you've had any luck convincing anyone else to do it in the past 10, 15 years compared to my attempts and others to do this. Because I think there's a lot of really simple techniques, and I think you highlight some of those of like, be it AS path filtering, no export, or whatever. But it seems like this is an ongoing lesson that we're going to continue to, or ongoing experience that we're going to continue to have, and we're maybe not learning it yet. So I'm curious your thoughts on that.
I'm a user of Facebook, and I know some of you are friends on Facebook. I was reminded of a picture 7 years ago in some random foreign country, and I was there to go spend 3-4 days at the NOC of a rather large telco in that country to help them understand how to do better routing and filtering. The network is still operating in the same mode that it was when I was there 7 years ago, and no. A lot of people, NSRC is a good example of an entity that puts a lot of effort into this. If anybody else walks out of this, if anybody walks out of this talk or out of this session and says, oh, I really should go actually make sure that we aren't susceptible, then great. If you don't think that, well, you should. Because unfortunately, this stuff hits anyone. Whether it hits Akamai, Cloudflare, we can only protect ourselves so far. We are, quite frankly, reliant on everybody else to do their part. And yes, I have. No, it doesn't help, but I keep standing on stage and taking more time than I should. I'm around if anybody wants to find me. Thank you very much.